Hello everyone, welcome to Soil Mechanics Laboratory. Today I want to take you through the consolidation test, and for you to be able to determine the consolidation of a soil, you need to use the odometer apparatus. And the odometer apparatus comes with some parts, so you'll find it has a dial gauge, the lever, the loading lever, the consolidation cell, and inside the consolidation cell, you'll find two porous stones for the bottom and for the top. And also, you'll find the plunger to distribute the loading. In the consolidation, the load is exerted axially. And for that also, you need a soil sample passing through the 2.36 millimeter sieve. So whatever is passing is what I'm going to use for this test. Then I'm going to weigh the amount that I've already calculated using the compaction parameters. You will need water for mixing the sample. You'll need the weighing balance for weighing the material, and also you'll need your data sheet. So let me take you through how to prepare and load the soil into the consolidation ring. This is the consolidation ring. So before you also use the ring, you need to know its weight. You also need to know the diameter, the dimensions, the diameter and the height, so that you'll be able to calculate the volume of that ring. So I already weighed my material here. So what I'm supposed to do now is to mix it with water and then mix it well and put it into the consolidation ring. So the water was already calculated. We mix until it is homogeneously mixed. I'll now transfer the soil that is mixed into the ring. You have to make sure you don't lose any soil particle because it is calculated. You compact gently, you don't overdo it. So after making sure that all the soil particles have gone inside the ring, you weigh the material plus the ring and then you record it on your data sheet. So while you're placing it, you have to make sure that the porous stone is at the bottom. Then you put your ring plus specimen, then the top porous stone, then the lock nuts. You lock it centrally. Then you take it to the loading frame. Make sure that plunger is there. Then depending with the density of that soil, you can decide on the loading to start with. And in my case, I'm going to start with the 50 kilonewtons per meter squared loading. And you have to make sure that the lever is horizontally straight. You can use a spirit level if you can't be able to tell. Then you set your dial gauge, and remember the dial gauge has a factor because the readings there are in divisions, but to change them into units you have to use the dial gauge factor. Like for this dial gauge is 0.01 millimeters per division. I'll set it. And also when you are setting the initial reading, you have to give it a high figure, since you don't know how the soil will consolidate and you don't want to get negative readings. So in my case, I'll use the inner small ring to give me the reading. I've decided to use 2300. So in the inner small ring dial, it will be pointing at 23. Then I'll zero the dial. So that's my initial reading, 2300. And the first pressure is 50 kilonewtons per meter squared. So after that, and you've checked that everything is set, you check your timer. You have your stopwatch ready. You look, everything is okay. Then you flood your sample. You saturate it. Until it covers the sample. Then you check at the time intervals you're supposed to get those readings. Like 0.25 of a minute is 15 seconds. You go 1 minute, 2 minutes, 4 minutes, up to 100 minutes. Then you can be able to take after 2 hours. Then you leave your specimen to run up to 24 hours before you change the loading. So we are going to start our timer. Make sure that everything is at 0. Even your stopwatch is at 0. So you let it run while you start your timer simultaneously. So after 15 seconds, that is 0.25 of a minute, I'm going to take my first reading. There you go. It has reduced to 2289. Then the data tells me I should take again after 1 minute. I'll let it run. There's my 1 minute. It has gone up to 2288. So remember my initial reading was 2300 and it's going on the reverse, meaning the sample is consolidating and the height is reducing. That's why you can see it's going on the anti-clockwise side. So again, I'm supposed to take at 2 2 minutes 15 seconds. Okay, there you go. You get the reading again. It has moved a little bit. It's at 2287.5. You let it go again, run. Our next reading is at 4 minutes. So our 4 minutes there. Now you get the reading again. It's still at 2287.5. So you continue like that up to the final time that you're supposed to take the reading. That is after 24 hours. Then after 24 hours, you're supposed to lock and double the loading. So each and every time you double the previous loading. So I'll show you how to do that. So when after 24 hours has elapsed, what you do, you lock it again so that the consolidation doesn't continue. You note the final reading, that was 22. So my initial loading was 50. And remember, when you are removing that loading, you have to hold it there, because if you don't, it will expand and interfere with the final reading. Then you double the loading. So your final reading is your initial reading for this next loading. And then you proceed with the experiment, meaning my first loading was 50. Now my next one is 100 kilonewtons per meter squared. So my final reading at 50 is my initial reading at 100. Then I repeat the same procedure up to the 24 hours. And then I continue like that up to the fourth loading. After the fourth loading, what you're supposed to do is you remove your specimen from the loading cell and then remove it from the proving ring. So you remove the sample from the loading. This is after the test. And you determine the moisture content at the end of the test. And that will help you to get the degree of saturation of that soil. So you transfer everything into the moisture dish. So you'll determine the moisture content by getting the wet soil plus the container. You weigh, and then you record it at the back of your data sheet. That is after the test. You record the container number, then the container plus wet sample. Then you take your sample to the oven for 24 hours. And then after 24 hours, you get the dry weight plus the container and also the empty container. And then you calculate the moisture content at the end of the test. So after you've done that, for you to be able to tell the change in thickness at each particular loading, what you do at each dial gauge reading, the initial and the final, you subtract the final from the initial and you multiply by the dial gauge factor to give you the change in thickness in millimeters. So you do that for every loading, and after you've done that, now you are able to plot a graph either using the square root time fitting method or the logarithmic time fitting method, and then you'll be able from that graph to get the consolidation parameters. That is the CV, the MV, and the settlement. Thank you.